Imagine a ship so powerful it outguns entire nations. The USS Gerald R. Ford, a $13 billion marvel of naval engineering. Hidden within its steel city are technologies that seem ripped from the future: electromagnetic jet launchers, laser-guided cannons, and more. Today, we'll reveal the science and engineering behind this floating fortress. How do you launch a 75,000-pound jet in 3 seconds? How do you stop a supersonic missile swarm? The answers are ingenious. Welcome to Aviate Hub. Subscribe for more mind-blowing engineering. Let's dive into the electromagnets, missiles, and secrets that make this ship the most formidable on the seas. First up, launching jets with pure electromagnetic power. Picture this: a 35-ton fighter jet, fully loaded, needs to take off from a 300-foot runway. The old steam catapults were powerful but brutal. One setting, full force, every time. Enter EMALS, the electromagnetic aircraft launch system. Using a linear induction motor, EMALS unleashes a wave of electromagnetic force, hurling jets skyward with precision. Unlike steam, EMALS is tunable. Computers adjust the force for each aircraft, reducing stress and extending lifespan. The result? Smoother launches, less wear, and more missions per plane. EMALS can launch a 70,000-pound FA-18 to 180 mph in just over 2 seconds, managing millions of amps in the process. It's not just faster, it's smarter, more efficient, and a game-changer for naval aviation. This system means more sorties, less maintenance, and a leap in carrier capability. The Ford's EMALS is the ultimate slingshot, redefining how carriers project power. It's a marvel of controlled chaos, launching the future of air combat. Next, let's see how they catch these jets when they return, because what goes up must come down, safely, and that's where the next breakthrough comes in. Launching jets is only half the battle, landing them is even tougher. The solution: advanced arresting gear, or AAG, the smart catcher's mitt. Instead of brute force hydraulics, AAG uses a massive electric motor and a water twister to absorb energy smoothly. When a jet's tail hook grabs the cable, the system converts kinetic energy into electricity, then safely dissipates it as heat. The real magic is in the software. AAG adjusts braking force in real time, handling everything from drones to cargo planes. This flexibility means safer landings, less stress on airframes, and longer aircraft life. The Ford's AAG isn't just an upgrade, it's a total rethink, making landings safer and more reliable. It's a leap forward for both pilots and planes. With EMALS and AAG, the Ford launches and recovers aircraft with unmatched efficiency. But what about defending the ship itself? Let's look at the first layer of its high-tech shield. Because on these seas, threats come fast, and from every direction. Time to meet the ship's guardian angel. Enter the evolved Sea Sparrow missile. The Ford is a prime target, so it's wrapped in layers of defense. The first, the RIM 162 Evolved Sea Sparrow Missile, or ESSM. ESSM is built to intercept sea-skimming, supersonic anti-ship missiles, those that appear with only seconds to react. With speeds over Mach 4 and extreme maneuverability, ESSM can outturn and destroy even evasive threats. It uses semi-active homing. The ship's radar paints the target, and the missile homes in on the reflection. Thrust vectoring lets ESSM make high-G turns, ensuring a direct hit. The Ford's vertical launch system can quad-pack 4 ESSMs per cell, maximizing firepower. This dense loadout means the ship can handle saturation attacks, multiple missiles at once. ESSM is the first shield, swatting down threats before they get close. But if something slips through, the Ford has more tricks up its sleeve. Next, we meet the last line of defense, the ship's robotic gunfighter. Because sometimes, you only get one last shot. Let's see what happens when seconds count. Enter the Phalanx CIWs, the ultimate get-off-my-lawn weapon. If a missile gets past the ESSMs, the Phalanx CIWS stands ready. Nicknamed R2-D2 with a minigun, this autonomous system detects, tracks, and destroys threats in seconds. Its M61 Vulcan cannon fires 4,500 armor-piercing rounds per minute, enough to shred incoming missiles mid-air. The Phalanx's radar tracks both the target and its own bullets, adjusting aim in real time for pinpoint accuracy. When a threat is detected, the dome swivels, the gun elevates, and a burst of tracer rounds forms a deadly wall. The result? Missiles vanish in a puff of smoke before reaching the ship. It's the Ford's final, brutally effective shield. But the Navy wanted even more range and flexibility. Enter the rolling airframe missile, an agile bodyguard for close-in threats. Because in modern warfare, layers of defense are everything. Let's see how the RAM system bridges the gap, and why it's a nightmare for anything that gets too close. The Ford's defenses are just getting started. Next up, the agile bodyguard. Meet the RAM. The phalanx is great up close, but the rolling airframe missile, or RAM, extends the ship's reach. RAM is a fire-and-forget missile, launched from a fast-slewing 21-missile honeycomb launcher. Its secret, the missile spins in flight for stability like a football, and uses dual-mode guidance. First, it homes in on enemy radar signals. Then, it switches to infrared, tracking the heat of the target. This makes RAM nearly impossible to decoy or jam. It can engage supersonic missiles, helicopters, and low-flying aircraft, anything that slips past the outer layers. RAM bridges the gap between medium-range ESSM and point-blank phalanx, creating a near-impenetrable bubble. Any threat must survive a gauntlet of increasingly lethal defenses. The Ford's layered shield is a nightmare for attackers, but not all threats come from the sky. Sometimes danger comes in swarms, fast, small, and close. Let's see how the Ford handles the swarm. Enter the Mk-38. Not all threats are high-tech missiles. Sometimes it's swarms of small explosive-laden boats. The Mk-38 25mm machine gun system is the answer, a stabilized, remotely operated cannon designed for close-in surface defense. Its M242 Bushmaster chain gun fires explosive shells, each a mini-grenade, devastating against small boats. The turret stays locked on target, even as the ship rolls, thanks to gyroscopes and electric motors. Operated from deep inside the ship, gunners use high-def cameras, thermal imagers, and laser rangefinders for pinpoint accuracy. The fire control computer calculates the perfect lead, ensuring first-round hits, even in rough seas. The Mk-38 keeps the little guys at bay, protecting the carrier from asymmetric swarm attacks. It's a brutally efficient system for messy close-in fights. With this, the Ford is ready for threats from every angle. But to use these weapons, you need to see the enemy first. Let's meet the ship's all-seeing eye, the SPY-3 radar. Weapons are useless without vision. The Ford's AN/SPY-3 multifunction radar is its all-seeing eye and brain. Unlike spinning dishes, SPY-3 uses fixed ASA panels, thousands of tiny radar elements steering beams electronically. It scans, tracks, and targets hundreds of threats at once. From high-flying missiles to low stealthy boats, operating in the X-band, it delivers razor-sharp resolution, distinguishing friend from foe with ease. SPY-3 feeds data to the ship's combat system, automatically assigning the right weapon to each threat. It's the central nervous system, tying every defense together. Without it, the Ford's arsenal would be blind. This radar makes the ship's layered shield possible. It's the ultimate multitasker, seeing, identifying, and prioritizing threats in real time. The Ford's edge isn't just firepower, it's information, and that's what keeps this floating fortress untouchable. Now let's wrap up with what makes all this possible. From electromagnetic jet launches to a multi-layered shield of missiles and guns, the USS Gerald R. Ford is a masterpiece of systems engineering. Its genius lies in integration, every system working in perfect harmony. This floating fortress is built to dominate today's battles, and tomorrow's unknowns. Behind every weapon is a story of human ingenuity and relentless problem-solving. Next time you see an aircraft carrier, remember, it's a hub of the world's most advanced science and engineering. If you enjoyed this deep dive, check out our other videos on the science behind military tech. Thanks for watching. See you next time.